Hello. Okay, today we're going to do some review of exponent properties to help you with things we've been doing recently. This is the beginning on 12C. I know I've got a lot of 12s in our packet. I circled a few that I'm going to do, and then I'm going to leave some of them left for you. If you ask me to do a particular one, of course I will. Otherwise, these will be the examples I'm providing. Evaluating, we've already done and been quizzed on, quite frankly, so we're going to revisit it. When you plug in, because I got to be honest, on your last quiz, which I'm going to show you today, there were some big time errors on this particular type of question right there. So evaluating this means plugging in, of course. So we have 3 times 2 to the second. I don't know why I did this one, because that's like one of these super easy ones here. You multiply first. You want to do order of operations in the parentheses first, then square. So it's going to be 6 squared, which of course is 36. Now the second one, we're plugging in -5 for B, and then we're cubing it. The first step is to follow the order of operations, which is to do what's in the parentheses, but there's nothing to do in there. It says then you do exponents, so we're going to do the exponent part. -5 to the third means -5 times -5 times -5, which is -125. And then multiplying that by 2 would give us -250. Thinking that's kind of probably enough of this. So let's just move on to a few down here with evaluating with some negative numbers that, and all these crazy negative and things in parentheses. Number 7, you're putting in -10 for x, which means you're doing the opposite of -10 squared. You apply the opposite to the -10, which gives you +10 squared, which is simply 100. Now, when you're doing number 8, -4 times -3 quantity squared, we need to know that we're going to do the squaring first. So that would be -4. -3 squared is -3 times 3. Do it in your head, because some of you are not typing things. You're typing things in with your calculator, and you're doing stuff like forgetting parentheses, and it's causing you to get the wrong answer. So this is -4 times 9, which would be -36. Here is the one that I'm talking about. We had an equation that was y equals -x squared, and you were to graph it, and I gave a t-chart, and I told you to put in -1, -2, 0, 1, and 2. And I had students write 4. I had them write 1, 0, 1, 4. And it might have been slightly different than this. It might have had +3 on it or something. What's going on? What's wrong with this? This is totally wrong. These are wrong. The only one that's right is the 0. And this makes the parabola go like that. And then I had people say the domain was -2 to 2. No. And the range was 4 to 4. I don't know. They wrote, you're just these numbers. You guys, this is a parabola. It opens down. These are supposed to be negative. Okay? Because when you put a number in here, even if it's negative, you're going to be squaring it and then applying the minus sign. The minus sign's not in the parentheses, like this one, number 7. You see the difference? This is very critical. So if I square -10, I get 100. And then I apply the negative sign to get -100. Anything you square is negative, that is true. But that's not what this says. This says the opposite of x squared. Okay? So you change the sign at the end. All of the answers coming out of this would be negative. All right, number 10. negative, we got x being cubed. I think I wasn't going to do this one, but I am now. And then I got a y. Oh, I put the wrong number in. I'm supposed to put a negative 10 in there, right? For x, I don't know how I did that. I just knew I was going to use the y in a minute. Oopsie, human error. And then y is negative 3. Okay, what do I do first? Cube it. Okay. So negative times 10 times negative 10 times negative 10 is going to be negative with 3 zeros, negative 1,000. Oh, I don't know why I have an eraser there, because I put the eraser away. But anyway, negative 1,000, that'd be negative, the opposite of negative 1,000 would be 1,000 times negative 3. So we get negative 3,000. Okay, that's all I'm doing on this page. So I'm going to skip. And talk to you about some exponent rules that you may have or may have not forgotten from Algebra 1. Okay, so I'm going to write down some of them. Oh, and I'm not going to use x's because all these are x's. Let's do something else. I'm going to use a b for base. Base to the b to the n times b to the m. What do you do with the exponents to simplify that? You b to the n plus m. You add the exponents. If you do b to the n divided by b to the m, you will subtract the exponents, n minus m, b to the n minus m. If you do b to the n raised to the m power, then you multiply the exponents, b to the n times m. If you have b to the negative n, you write the reciprocal, 1 over b to the positive n. Okay? So, using those ideas, number 12, x to the 9th times x to the 2nd, well, that's super easy. It's x to the 11. Oh, wow, I wrote a 11. I wrote the power. Well, I'll just stick an x down here. Okay. I wrote the exponent first. Okay, this would be division, so it means the same as x to the 9 over x to the 2nd. You subtract to get x to the 7th. The negative x is in the parentheses, so it's going to be the opposite of x to the 12th. But what would happen to that anyway? These are both positive, so it would be equivalent to x to the 12th. What's the exponent when there isn't one there? Okay, a 1. The phantom ones I told you about, or talked to you about. X to the 8th. And on 16, you got x to the 1st in the bottom, so you're going to subtract 1. X to the 4 minus 1 is what you're doing, and it's x to the 3rd. Was that enough writing? You think just a good review. Okay, now it says simplify the expression, do not solve. So that means we're not going to evaluate the number on our calculator if we could. We're going to use the rules. So if I've got 5 to the 3rd times 5 to the 2nd, the base is 5. You do not change it to 5 times 5 and 25 to the 5th. It's just 5 to the 5th. You leave the base alone and do the exponent rule. Okay, the common mistake is kids will multiply the 5 and the 5. So same thing for the next one. We have negative 5. We're going to add the exponents to be a negative 5 to the 11th. 19. 5 to the 8th divided by 5 to the 5th. You'd be like having 5 to the 8th over 5 to the 5th. You would subtract to get 5 to the 3rd. I think that's enough of that. All right, I'll leave a few to you, and I'm going to skip. Find the value of n that makes the statement 2. So we're kind of going in reverse with the idea. If 5 to the 7th times 5 to the n was equal to 5 to the 10th, what would n have to have been? Since the rule would be to add the exponents, you would need n to be a 3. Okay, if I wanted to show you how to do that algebraically, which probably isn't really necessary, it would be this. 7 plus n is 10, and then n would be 3 by subtracting 7 from both sides. That makes sense? Okay, here it's also this. I can skip that one. I'll skip that one. Let's go to 25, please. just circling the ones I'm doing. This is a division, so you would be doing 10 minus n. The rule would be to subtract, and you'll be getting 2. So that means that n had to be 8. And you probably didn't need to do an algebraic equation to figure that out. This one, the n is going to be 4 minus 4. Oh, it'd be m to the 0. So n, it would be 0. I don't know why I wrote all that. Be 4 minus 4. Okay, and I think that's enough of that. So now let's check out how you're going to do the puzzle, and I'm only going to do a couple, and then we're going to go to some harder problems on 12E and F. To simplify each exponential term, and at the bottom of the page, write the letter of each problem above the solution to spell the answer to the riddle. What do you get when you add 1 homework assignment and 1 homework assignment? I don't think it's going to say 2 homework assignments. Anyway, we need to remember what this rule is for negative exponents to do this page. So b to the negative n equals the reciprocal 1 over b to the positive n. So what would 1 over b to the negative n be? B to the positive n. Yeah, so you'd flip it over basically and change it. Okay, so if it's in the top, if it's up on it in the numerator, it can go down and become positive. If it's in the denominator and it's negative, it can come up and be positive. So we don't use any negative exponents in our answers ever. You're never allowed to leave them in your answer. Okay, 6 to the negative 2 is the reciprocal of 1. This is 1 over 6 to the negative 2, so this would be, and I'll prove it to you, the reciprocal of 6 to the negative 2 is 1 over 6 to the second. When you divide by a fraction, you change to multiply by the reciprocal, and it just gives us 6 squared, which is 36. So I would take the shortcut, wouldn't you? And just bring it on up, say 6 squared. Flip it over and change it to a positive exponent. On this one, we're going to add the exponents. Okay, so anyway, 36. I forgot what I was doing. I'm doing the easy one. So I'm going to. The reason that I give you a puzzle is because you can work it out, and if it doesn't make sense, you kind of know what happened, which ones you probably got wrong. So let's check out what we do to fill in the puzzle. You need to go to the bottom of the page. And see that there's a 36, and there was a letter M next to the problem. We just got the answer of 36, so we put an M over 36. Does anybody just spot one right now they'd like me to look at with you right now? So before we move on, because I'm going to do some harder ones that have these properties in it. Yes. Oh, not this one. This one. Okay, so negative 3 to the 0. Anything to the 0 is 1. So this would be negative 1, though, because 3 to the 0 is 1, and then you have to apply the negative sign. And then 1 over 3 to the negative 2 would be 3 to the second. So that's negative 1 times 9. This one is negative 9. Now, if that negative 3 had been in parentheses to the 0, it would have been positive 1. Okay, so we have to know anything to the 0 power is 1, but if there's no parentheses around the negative sign, it applies. So the answer to O is negative 9. And then you go down here, find negative 9, and you put your O. Okay, so please save the puzzle for homework, okay? That's an assignment just to work on when you get chance tonight. So go to 12E, please. That next page. You got your rules at the top that I went over already. The only one I didn't go over was this one. I don't think I really fully didn't write down x to the 0 is 1. Well, we want to remember, we did discuss this the other day. You remember the tree? You got your tree. And then you've got your roots. And they're brown. And I said that the roots is on the bottom and the power is on the top. Okay. Well, if you have an exponent of x to the 1nth, 1 over n. The n part is the root index, and the power would be out here. Okay, you can put it out there. The rest of these I already explained, except for this one too. When you have a quotient, meaning a number divided by a number or whatever, raised to a power, you apply the power to both the numerator and the denominator, and you can evaluate them separately. Okay, and we've already done some of this in the last few days. So examples are given down here of how you might use these. So let's just go jump and do some of our own, because those are self-explanatory for you using the rules. Let's find something that just looking at that page, what jumps out at you is, ooh, I don't know how to do that, or I'm not sure. All right, first of all, tell me what 2 is. Someone? What would you do first? Anytime you look inside a parenthesis, see if there's something you can do. That's not, well, the answer is negative 1/15, correct. Because 15 to the negative 1 is 1/15, and then you apply the sign. So negative 1/15. Okay. I'm just looking, if you have, let's do, well, number 6 is apply the power to the top and the bottom, and then you just evaluate. So this would be 9/25. You just square both of them. Number 7, and I'll just pick out a few here. You're going to flip it over and then change the power to a positive power. You do the reciprocal of what's in the parentheses, then your power is positive, and then you evaluate 25. 5 squared. Oh, okay. Explain, because this will be something we'll want to know. Why is anything to the 0, 1? All right, so powers do not ever make an answer 0. Okay? So let's think about this. 1 to the, I'll do numbers of 3. 3 to the first is 3. 3 to the second is 9. I was asked to explain why a number is to the 0 power is 1. 3 to the second is 0. 3 to the third is 27. Etc. 3 to the fourth is 81. What is 3 to the 0? Well, think about 3 to the negative 1. That's 1/3. 3 to the negative 2 is 1/9. 3 to the negative 3 is 1/27. 3 to the negative 4 is 1/81. What's going to happen in here? So if you see this as multiply by 3, multiply by 3, multiply by 3, that's what powers are. It's repeated multiplication. It's a representation of repeated multiplication by the same number. So what's 3 times 1/81? 127. 3 times 1/21 is 1/9. 3 times that, 1/3. 3 times a third is, okay, and a power never makes an answer 0. That was kind of a quick explanation of powers. Exponents. Yes, Scott. I can. Can you? I'm just teasing. I hope I can. Let's see. Okay, first of all, how do we want to make the negative 4 a positive 4? What could we do to the 1/2? Yep, do the reciprocal of 1/2, which would be 2. So this will be 2 to the 4th. And I gave you a present yesterday. Didn't you get a green present? Your green card? Oh boy, that was bad. I didn't even think about it being green either. Oh, and it has some squares, cubes, fourths, and fifths. Did anybody not get one yet? If you need one of these, I got more. Green card, okay, yeah. Oh, the timing is well just perfect, isn't it? Taka. Anyway, wasn't intentional. Yes. 4. Okay. 1. Haley? Sure. And does that say 5, 6? I was planning on doing that anyway, just like I'm going to do this, because that's why I was bringing up the green card. So you got your green card. What column will you look in? Remember, the bottom is a root. It's the 5th root. We want the 5th root of 32. Well, take a guess. It's got to be small. It's going to be something times itself 5 times the exact same number. Okay, so you see how your card can help you right now to get used to some of those numbers. In the column, the column of 5 or fifths or whatever it says on it, powers of 5, the first number is 32 because 2 to the 5th, and that's because 2 to the 5th is 32, and that's why the answer to this is 2. So, if we go over here to 11, we're doing the 6th root of 64, and then we're going to take it to the 5th power. Well, if the 5th root of 32 is 2, and 2 times 32 is 64, then the 6th root of 64 is 2, and then we have 2 to the 5th, which we said is 32. So that's what I was talking about. We want to do the root first, and then the power. And that'll make it doable in your head. You can also type that on a calculator, by the way. But I really want you to understand this, because at some point, if you do not understand your exponent rules, you will not understand something we're going to learn, which is called logarithms. Logarithms are solving for exponents, okay? And they're related to this. So understanding this is really helpful to later on. So I don't just make you do it because you can't, typing on the calculator is not what we need to know. All right, this one says negative. All right, I go ahead and do this, I guess, because you see the negative sign? When's it going to be applied? Oh, are you squaring it, though? Is there a parenthesis around that? All right, no. So you're going to be doing the opposite of the cube root of 27 squared. This answer is going to be negative. The exponent is not what's negative, so it's not a reciprocal. Okay, that negative sign applies to what you're going to get at the end. You need to first do the cube root of 27, which is, you can look at your card if you're not remembering. No, cube root, look in the 3's column. 3, and then you're going to square 3, and then you're going to apply the negative sign. So this is negative 9. Hush is preferable in the beginning. Then when it gets obnoxious, you go there. All right, got some more here. What looks fun? Like you want to do this in your evening free time. Yes. Okay, excuse me, Adeline is asking me a question. Yes, ma'am. Okay, I put this in parentheses to help you understand that I need to do this before I apply the negative sign. That's not, this is like it's in its own, there you go. Yeah, like that. That better? Okay. Or here, you can put, it doesn't matter where I put it, Ellen, I can put it here too. I still have to square that 3 and then apply the negative sign. And your fake twin is very meticulous as well. Yes. Simplify each expression, assuming that no variables equals 0. No variable equals 0. Write your answer with positive exponent. All right, can't have any negative exponents. These don't look all that bad. Let's do something like 18. Okay. Okay, here are your options. I would just apply the power, because then you're going to be done. Because what is 1 to the negative 6? Anything, 1 to anything is 1, okay? And then if you apply the negative 6 times the negative 7, you get x to the 42nd. This is just 1 over x to the 42nd. And can I not read? Oh, well, apparently my eyes are getting worse as time passes because you just told me that's a negative 5, not a negative 6. I have trouble seeing that on this tiny paper, apparently. It's kind of blurry. Better? There's your answer, 1 over 35. All right, the rest of these are really not so terrible. So let's pop over to the next page. I'm leaving them to you. You can ask me later. Okay, let's go to F and start looking for something crazy. Haley, if you insist, madam, I have no problem. 16. What's the rule? Oh, Scott's the one that wanted it. What's the rule? Yep. N. Well, oh, I should have done a different base. B to the M. That doesn't sound. I don't want to use BM. Let's do. The rule was B to the N to the M, and you multiply the exponents. Yes. 13. Add the exponents. D to the negative 1, 1 over D. Multiply like bases, add the exponents, and then if it's negative, make it the reciprocal. So how many times has Haley taken your, like, spoke up for you? I'm teasing. Oh, that was the first time? Go once. All right, so next page. May somebody want to pick one? Which one? 36, okay. Oh, I was going to do that one. Oh, that's nothing. No. You'll have, this will be, yeah, that's definitely a quiz question. Guys, okay, you got to practice. When you practice, you start knowing what to do because there's so many ways to do some of these, and the order is practicing them. It helps you learn what's the most efficient order and get insight. So I'll give you some hints, okay? Let's talk about a hard one like 36. You have options. I look inside here, and I see I could do some stuff right in here already. But I don't feel like it because I got this negative exponent out there. So I think what I'll start off doing is getting rid of it being a negative 4. So what would be the way to do that? Instead of multiplying it times all of these things in here, I'm going to have a ton of negative exponents then, which would make me crazy. I'm going to just flip it over, all right? And that'll become a positive 4. So I'm going to write 2m p to the third over m to the negative 2 p to the second, and then all I've done is flip it over, so I changed the negative 4 exponent on the outside to positive 4. Okay? Now, there's a rule that says, we just discussed it, b to the n to the, to the m power, ignore the dot, is b to the n times m. So I'm going to apply the power of 4 to every single piece in here. I flipped it over. It means the reciprocal. So I flipped over the fraction so I could change it to a positive 4 power. Are you guys with me now? All right, now I'm going to raise all of these to the 4th. So it's going to be 2 to the 4th, m to the 4th, p to the 12th. I multiplied. All right, don't forget to do the 2. All right, now multiply on the bottom, m to the negative 8, p to the 8. Now we are going to use the rule for division, which tells us to subtract the exponents. So evaluate 2 to the 4th. You don't need, there's nothing else, no base of 2 on the bottom. So that's 16. 2 to the 4th is 2 times 2 times 2 times 2 is 16. I have m to the 4th minus negative 8. And I've got p to the 12th minus 8. That's what I'm doing, the step I'm doing. And now I can write my answer. 16 m to the 12th, p to the 4th. Not that bad. Got a little writing. What's the matter? What? Oh, tell me where you're not seeing what I did. It's okay. Yes. No. 4 minus negative 8 is 12. Positive 12. 4, okay, you take the bottom exponents away from the top exponents. 4 minus negative 8 is 12. The rule is to subtract the exponents. Okay, otherwise, guys, you could go, all right, got 2 to the 4th. I'm going to move my m's that are negative up or down. And this isn't, I mean, I still just got to subtract those. You know, I don't know, there's still 12. I can explain this lots of ways, but I'm hoping you followed that because I thought that was the easiest way to do it. All right, we want to pick another one. 42. Oh, that's just a repeat of the page I just did. Oh, those look fun. Oh, let's do 38, and then we'll go to the 32. You mind? Probably not. What do you got to do first? Now look at this. I'm not going to, you see that there's a power on the outside of a parenthesis. That's what you got to take care of right now. Do first. Okay, so I just rewrite 2x cubed y squared. And then I have to apply that 2 power to everything inside there. So it's 3 to the second, x to the second, y to the what? Not 5, but 6. That's when you multiply. You don't add, you multiply them. All right, now I'm going to do 2 times 3 squared, 9. 2 times 9 would be 18. Your rule is to add the exponents, x to the 5th, y to the 8th. Okay, I'll go to 42 now as you requested. Okay, insight. First thing is to look that you have 2 separate things. One's a bracket, they're both brackets, it's just different kinds of brackets. Okay. I see I could apply 4 to all of these in here. So I'll do 3 to the 4th, x to the 4th over y to the 4th. Okay, so I simplified that first one. Now I'm going to simplify the second one. But what do I need to do because I have a negative exponent? All right, let's just flip it. Y to the 3rd over x to the negative 8. I didn't change any signs. But I do still have it squared. So you guys decided to flip it. We had a different option, which would have been easier. I think we should just multiply them. And do you see why now? Because one's going to be negative and one's going to be positive still. So it's going to be x to the 16th over y to the negative 6. So I decided not to flip it. All right, now, when you multiply fractions, you multiply numerator times numerator, denominator times denominator. So I'm going to do that. I'm going to multiply across. 3 to the 4th is 81. It's in your chart on your green paper. X to the 4th times x to the 16th would be x to the 20th. You would add the exponents. And then on the bottom, you're multiplying y to the 4th times y to the negative 6. You would add the exponents, y to the negative 2. But we're not allowed to leave that guy all in our basement lonely. He's feeling negative. We want to make him positive and happy, so we're going to bring him upstairs to join us. 81, x to the 20th, y to the 2nd. He's happy now. Don't leave your radicals in your basement either. Blow up your house. Okay, let's do 43, and then I'm going to pass back your quizzes. All right, 2x minus 5 times 2x minus 5 times 2x minus 5. I gave you a clue the other day. You cannot just cube what's in the parentheses. This is what it means. So I'm going to multiply these out. 4x squared minus 10x enters minus 10x plus 25. All right, I only did the first step. Okay, now I'm going to simplify that. 4x squared minus 20x plus 25. Now I've got to multiply that by 2x minus 5. So here's what this is why I told you I do not like foiling. 4x squared times 2x squared is 8x to the third. 4x squared times minus 5x is minus 20x squared. Negative 20x times 2x is negative 40x squared. Negative 20x times negative 5 is plus 100x. And I'm still not done. Now I got to multiply 25 times those. So I've got plus 50x and then minus 125. So my final answer, 8x to the third. I've got minus 20x squared minus 40x squared, which is minus 60x squared. I have 100x and a 50x, so that's plus 150x minus 125. So aren't you glad I'm not going to ask you to do a bunch of those? How would you like to do the fourth power? Okay, have a great evening. Finish the rest of the worksheets. Practice, practice. Heimer time is over.